Okay, spend some time graphing some points on the polar axis. Again, keep in mind the first coordinate is always your radius, or the distance away from the pole, and then this is the corresponding angle. Usually what I do is I graph the point first, the angle first, and then I'd find the corresponding radius or distance away from the pole, and then you're all set. My angles can be positive or negative, so if it's positive, it goes in a counterclockwise. If it's negative, it goes in a clockwise direction. And my radius as well can be positive or negative. So in this case, it's 3 comma pi over 2, so let's just graph that. So pi over 2 is the one that's straight up and down, and 3 is 3 away, so here's 1, 2, 3. So here's my point right here. I'll make it pretty fat so it's pretty clear. That's my point. Just keep in mind that if you have a negative radius, and we'll see that in a second, as opposed to going up 3, you would go down 3. So you'd go to the corresponding angle and then just go in the opposite direction, and we'll see that in an example in just a minute. So that's it. Just graphing a polar point. You just go to the corresponding angle and then how far away from the pole, and then you draw a dot, and then there's your point. And obviously we can draw functions and draw some graphs, but right now we're just dealing with doing points. So we'll do another example. So this one is kind of confusing to me. This looks like a Cartesian point or a rectangular point, but it's not. We're still on the polar axis. So just keep in mind the first one is the radius, and the second one is my angle. So my angle is 0, so therefore I'm on the positive x-axis because this is the angle 0. But notice that my radius is negative 2, so as opposed to going out to 2 to the right, I just go the opposite direction in a distance of 2. So I go over here to negative 2. So the negative just denotes use that angle, the original angle that you had, but just go in the opposite direction. So as opposed to going to the right 2, in this case, we're going to go to the left 2. So really this also could be known as a radius of 2 and an angle of pi. So 2 comma pi and negative 2 comma 0 are the same points. And we'll see more about that later. So in here our polar axis is a little bit larger. I did that on purpose because we have 5, so therefore I just made the polar axis a little bit larger, and negative pi over 6. So the thing to keep in mind on the polar axis that I have here, each one of these is pi over 12 or 15 degrees. So here's negative 15, here's negative 30, negative 45, negative 60, negative 75, negative 90. Or this is pi 6, pi 4, pi 3 in the negative direction. So this is positive pi 6, pi 4, pi 3, and then pi 2. So the first 2 are skipped in each quadrant because that's pi over 12 or 15 degrees, or 75, however you want to look at it. All right, so bottom line is we need to go a radius of 5 in a negative pi over 6 direction. So negative pi over 6 would be this way. 5 would be over here, so here is my point right here at 5 comma negative pi over 6. So we have 5 pi over 3 and negative 4. So again, this is my radius and this is my angle. So 5 pi over 3, well, we always skip the beginning 2. I know I'm in the 4th quadrant. So this is 5 pi over 3, this is 7 pi 4s, and this is 11 pi over 6. So I want 5 pi over 3. So 5 pi over 3 is going to be this one right here. But I don't want to go out 4. I want to go. I don't want to stay 4. I want to go negative 4. So that means I want to go to the pi 3 angle that's in the 2nd quadrant, which is 180 degrees or pi radians away. So I go back around to this is the pi 3 in the 2nd quadrant because it's diagonally across from this one here, or 180 or pi radians away. And I want to go out to 4. So here's my point. So my point is negative 4 comma 5 pi 3. Why does this thing keep leaking? It's kind of annoying. Okay, so notice when it's a negative radii, you go the opposite direction, and 5 pi over 3 was this angle in the 4th quadrant, so we go over to the one 180 degrees or pi radians away in the 2nd quadrant. So the pi 3 angle that's in the 2nd quadrant. So in this case, both my radii and my angle are both negative. So first thing I want to do is go negative pi over 6. Well, this is my pi 6 angle in the 4th quadrant, so here's my pi 6 angle in the 3rd quadrant. That's negative 5 pi over 6, which would be over here. And I need to go out negative 3, so that would be this point right here. But then since it's a negative radii, I need to go 180 degrees or pi radians around, so either direction doesn't really matter, but that dumps me back into the first quadrant. So I want to do the pi 6 angle that's in the first quadrant, which is this one here. I want to make sure that I'm 3 radians out, excuse me, radius of 3 out. So that's this point right here. So this is -3, -5 pi over 6. So here I have 0, comma, -5 pi over 3. So 0, -5 pi over 3. So -5 pi over 3 is going to be back around in the first quadrant right here. But notice that my radius is 0, so that's the same as being at the pole right here. So my point, though it's kind of hard to see, is right at the pole. So my point is, because my radius is 0, so it doesn't matter what angle I have. If my radius is 0, I'm going to be at the pole. So there's an infinite number of ordered pairs that we could have that would correspond to being at the pole, because if my radius is 0, it doesn't matter what angle this is. Here's my last example. We have 4, comma, -13 pi over 6. So this is clearly larger than 2 pi. So -13 pi over 6 is the same as -12 pi over 6 minus pi over 6. So this is just an extra rotation in the clockwise direction. So just -pi over 6 is going to be the one down in the fourth quadrant. And I want to be a radius of 4, not radii, radius of 4, so that puts me at that point right here. So just like in the unit circle, you can have coterminal angles or extra rotations around. This way we went a clockwise direction of extra 2 pi. That dumped us down into the fourth quadrant, -pi over 6. So here is my point 4, comma, -13 pi over 6. And hopefully you notice that I could also write this as 4, comma, -pi over 6. That's going to give me the same spot. And finally, it could be 4, comma, 11 pi over 6. And we'll spend some time looking at different ways to represent points on the polar axis.